Okay, here is a diagram which we will complete to make it the rock cycle. Okay, so let's start with some rocks. We've already got some rocks. That's just a thing. Great. What could happen to the rocks? Well, they could be weathered. So we start with weathering. Now, weathering and erosion are not the same process. Okay, so we've got these two things going on, weathering and erosion. Weathering is the breaking down of rocks into either smaller pieces, that would be mechanical weathering, or into simpler chemicals, that would be chemical weathering. But weathering has to happen before erosion because they're completely separate processes. Erosion is then the movement of the weathered rock. So the rock up in the mountain, over on the left of the diagram, we've got some mountains there. The rocks get weathered, they get broken down, and then that little pieces of rock get washed away in the streams. That washing away is the erosion part. So we have weathering and erosion. Now, those little pieces of rock that have been mechanically weathered, they will be deposited somewhere along the way as sediments. So we have sediments just on the surface of the earth, wherever they get deposited. Actually, let's put that in deposition. Going along. So weathering and erosion, and then the sediments get deposited. So they're on the ground. Now, eventually, multiple layers of sediments will build up and be compacted. They'll be squashed together and glued, kind of stuck together. So we talk about compaction and cementation. And this, of course, is how we form our sedimentary rock. So first of the actual rock types on this rock cycle here is sedimentary. Now, okay, great, we've got a rock now. We've just made some new rock, some sedimentary rock. That could be uplifted due to tectonic activity. So those rocks can come to the surface again and be weathered and eroded. And there's a little cycle. It's not the complete rock cycle, but it is a cycle that could happen. So we could have uplift, because of course that sedimentary rocks are formed underground. So we've got uplift due to tectonic activity. Okay, so plate tectonics. And then the whole thing could start all over again, get weathered and eroded, be deposited, have some sediments build up, make some sedimentary rock. Now, that sedimentary rock may not be uplifted. It might actually go be forced deeper into the ground. And due to the extra high heat and pressure, the rock can change. And so that will give us a different type of rock, metamorphic rock. Now, that metamorphic rock, like the sedimentary rock, could actually be uplifted due to tectonic activity. So you'll note there's an arrow coming from metamorphic rock going up as well. So we've got two cycles there. We could go from the sediments to the sedimentary and then be uplifted, weathered, erosion, back to the sediments, or we could go further down to the sedimentary to the metamorphic rock, and then that could be uplifted, and we've got two little loops so far. However, this rock may not be uplifted. It may be going down further into the mantle, where we'll find magma. Now, this is plasticized rock. Note, it is plasticized rock. It is not liquid rock. The magma in the mantle, we have convection currents going around, but it's not actually a liquid. It's acting like a liquid, but the rock is still technically a solid. So we describe it as being plasticized rock, or being plastic in nature. Anywho, that magma could come out of a volcano. So let's follow this arrow on the right, the big long one that comes all the way up. We've got the magma coming out of the volcano. We'll change its name. We'll call it lava, etc., etc. But then it will cool down and harden into, well, it was already solid, remember, but it was plasticized solid. But it will cool down and harden into what we normally generally think of as solid, hard rock, right? So rather than this plastic rock. Now, when that cools down, we will give it a new name, and we call it extrusive igneous. Okay, extrusive because it has come out of the volcano, right? So X meaning out. We have extrusive igneous rock. Igneous coming from the word ignis meaning fire, because it came out of a volcano, which is of course not fiery, but anyway. So we've got extrusive igneous rock. Now, igneous rock, well, extrusive igneous rock has another name. It came out of a volcano, so we can also call it volcanic rock. Now, we've got an arrow going off to the left because this igneous rock could also be weathered and eroded and broken down to our sediments, and so we're going around and around and around. Now, there's one arrow left. Now, this magma, maybe it doesn't actually come all the way out of a volcano. Maybe there's a movement of the magma up into the lithosphere or the crust. It doesn't actually come out of the surface, but it has moved further away from the mantle, so it is going to cool down and solidify again, become not plastic in nature, but a nice hard solid. So this is, again, igneous rock. But it's staying in the planet on the inside. So instead of extrusive, which exited the inside of the Earth, this is still inside the Earth, so it's intrusive. So we actually have a couple of types of igneous rock. We have extrusive igneous rock. That's the stuff that comes out of the volcano. And we have intrusive igneous rock. That's where the magma moves out of the mantle, and so it does cool down, but it's still within the planet. Now, this has another name as well. This is plutonic. So the magma coming out of a volcano forms volcanic rock, but the magma that stays inside the Earth and slowly cools down forms plutonic rock. Yeah, and there we go. There is a rock cycle. Yeah, sorted.